Hello students, this is Mrs. Crumpton. This lesson is section 8-2, multiplying a polynomial by a monomial. It comes from your Glencoe Algebra 1 book, pages 472 through 476. Your learning target for this section is, I can multiply a polynomial by a monomial. I can solve equations involving the product of monomials and polynomials. We're going to start out with a problem that hopefully will refresh your memory on distributive property and your exponent rules that you learned exponent rules recently, and distributive property, which you learned a long time ago. First off, we're going to take this 6y and we're going to distribute it to each term within parentheses. I'm going to rewrite the problem so that you can see your original problem and you can watch me and go along with me as I do the distributive property. So I'm going to distribute that 6y to every term inside parentheses. Now you can write it like this. You can put 6y times 4y squared minus 6y times 9y minus 6y times 7. Let me be consistent with my colors. You can show your work that way, or you can go straight to your answer, which is the way I'm going to show you. Be a little bit more time saving. What you're going to get when you multiply these, you're going to multiply the coefficients. 6 times 4 is 24. Then follow your exponent rules. You have the product of powers, the product rule. You've got 6 to the y power times 4 to the y to the second. 6 times 4 is 24. Y times y to the second would be y to the 1 plus 2, which would be y to the third power. 6y times 9y. 6 times 9, of course, is 54. Watch your signs closely. Notice what I'm doing with the signs. And then y, even though we don't see it, these y's are raised to the first power. So we would have 54, y to the 1 plus 1, y to the 2. Then our last term here, we've got minus 6y times 7. Well, 6 times 7 is 42, and I need to not lose the negative sign. So I've got negative 42y. The big difference here with the distributive property is that we're distributing not only to the coefficients, but we are also distributing a variable. So take a close look at this problem. If you have questions or you don't understand, make sure that you bring those questions to class so that I can help you out. Okay, your next problem, we are going to simplify 3 times the quantity x plus 2, or x to the second power, minus 4x minus 15, plus 6x times the quantity 5x plus 2. Well, let's take this one group at a time, and I'm going to take this first. And I want to use the distributive property. 3 times 2x would be 6x to the second power. There's no variable being distributed this time. You're only distributing those coefficients. 3 times that negative 4 would be negative 12x. And finally, 3 times negative 15 would be negative 45. Okay, in the last section, I showed you how to stack up the like terms. We're going to do that here, but first, again, we have to do the distributive property. 6x times 5x would be 6 times 5 is 30. X times x would be x to the second power. And last for this set of terms, 6 times 2 would be 12x. Do we look like we're finished with this problem? Think on it a minute. Do you have any terms, like terms, that you can combine to clean this up? Yes, we do. Take a look here. We've got 6x to the second power, and we've got a positive or plus 30x to the second power. Now, since these are like terms, we're going to combine them. 6x to the second power plus 30x to the second power would be 36x to the second power. That's all you do on that part. Just got to keep going. Now let's see if we find another set of like terms. Your minus 12x plus 12x. What happens here? Think about those coefficients for just a second. If I were just saying negative 12 plus 12, what would that be? That would be 0. And 0x is just 0. So I'm just not even going to worry about putting the x term in there, because these two terms canceled each other away. And last but certainly not least, we have a constant here. Now let's list these things in order. 36x to the second. Next we're going with the blue, 0x, which I don't have to put in there because that's just 0, but I do need to put the minus 45. And you're finished with that example. I need you to think on it. Take some time, look at it. If you don't understand what I did, please be sure you ask me in class. And the last example that I'm going to give you for this example, I have one more after this. This example is a word problem, and it kind of gives us an idea of how we would work a word problem related to real-world activities. Admission to the super fun amusement park is $10. Wow, wonder where that one's at. I know Six Flags is a lot higher than that. Once in the park, super rides are an additional $3 each. Aha! So there's an extra fee. And regular rides are an additional $2. So this one is kind of like, this amusement park is kind of like going to the fair. You go to the park and ride 15 rides, of which S of these rides are super rides. Find the total cost in dollars if you rode 9 super rides. First off, let's define our variable. Okay, we've got, we are asked to find the cost in dollars. So let's say that, of course, D is going to equal the cost in dollars. Before we can take care of that, we need another variable, which we are given to us here. It says you go to the amusement park and ride 15 rides, of which S of those rides are super rides. Okay, well now, if we're going to ride super rides, and S is our variable here, that's S is going to stand for the super rides. Since I'm going to have to go on to another page, make sure that you have this problem written down so that we can refer back to it. Now, our problem says that admission to the Superfund Amusement Park is $10. Okay, so let's start out with our D. Of course, that equals dollars. And regardless, you've got to pay the $10 fee to get into the amusement park. Next, it says that the rides, the super rides are $3 in addition to. So we're going to add, and why did I add here? Think about that for a minute. Am I taking away? Am I taking myself off of rides? Am I undoing rides? No. I'm going to use that $3 times the number of super rides. Also, regular rides are $2 extra. It says that Sarah goes to the park, or you go to the park, and ride 15 rides, of which S of those are super rides. Well, if I had 15 apples and I'm giving someone else some of those, then I would subtract the number that I'm giving away. This is going to be worked in a similar manner. Okay, $2 for the price of the tickets. There were 15 tickets sold. So if we can take the S, I'm going to change my S's to dollar signs so they don't look so much like a 5. Okay, now we're ready to use the distributive property before I do anything else. And I want to distribute the 2 to both of those terms. Okay, once I get all my distributive property done, I've got 10 plus 3S plus 30 minus 2S. Now I want you to come up with some way to identify your like terms. I like to use different shapes. Here's a like term. We've got plus 3S. And here's a like term. We've got minus 2S. So let's combine some like terms here. We've got 10 plus S plus 30. Now let's combine these like terms. And 10 plus 30 would be 40. So we've got S plus 40. Now the problem asks us to evaluate this expression if Sarah rode 9 super rides. So the number of super rides that you rode, I keep saying Sarah, the original problem had Sarah in it and I changed it to you to make it a little bit more personal. So the number of super rides is 9. All I'm going to do is simply replace or substitute 9 in for S, add 40, and the number of super rides is 49. Think on that one for just a little bit, and if you've got questions, be sure that you ask me in class and we'll take a closer look. In the last example, we are going to solve an equation that has polynomials on both sides of the equal sign. Okay, so what I'm going to do, because there's so much going on, I'm going to take and I'm going to separate this equation into 2 parts. Now then, before I do anything else, I'm going to do a little cleanup work and use the distributive property. Remember, that's hugging everybody in the house. So I got negative 4y, distributing negative 2 times 7 would be negative 14, minus 2y. Okay, now we've got some like terms over here together. We've got this negative 4y, and we've got minus 2y. Same signs, add and keep. So that would actually be negative 6y minus 14. Okay, now got a little cleanup work done, so I'm going to move over to the right side. Can't do anything else with the left side because they're not like terms. Okay, so I'm going to go back to my good buddy distributive property. I'm going to say 4 times negative y would be negative 4y. Then I've got 4 times negative 3. That would be negative 12. Then don't lose that plus 4 there at the end. Okay, now let's see. Do I have any like terms here? I believe I do. I have constants that are like here and here. So negative 4 plus 12. What is that? Think about it a minute. Hope you said negative 8 there. Negative 4, let me get the right color. Negative 4y minus 8. Now we're down to something that looks a little more familiar to you, I hope. Let's isolate y to one side of the equation. Okay, I'm going to start out by moving that negative 4y by adding it to both sides. Plus 4y. Okay, now it's gone over here. Negative 6y plus 4y would be negative 2y. I'm going to take care of 2 steps here. I'm going to go back up to this 14, negative 14. Since I'm trying to isolate y to the left side, I'm going to move this 14 over to the right side by adding it. Negative 8 plus 14 is a positive 6. The last thing that I'm going to do here is solve the equation, which we've now gotten down to a one step, by division. Negative 2y means negative 2 times y. I'm going to draw my fraction bar in here, divide by negative 2, and y equals negative 3. Look over that example. Do you understand each step? Let me mark this out. Maybe that'll help a little too. If there's anything you have question about, be sure you write down your question so you can bring it back to class and ask me. Alright students, now you are ready for just a little bit of formative assessment. Here are the problems for your formative assessment. They come from page 474, problems 1 and 5, 7 and 9, 11 and 17. Please be sure you check your answers in the back of the book, and if you have any questions about the formative assessment problems, you need to bring those to class so we can take care of those questions together before you do your graded assignment. That graded assignment, heads up, it is from page 475. It will be numbers 19 through 41 odd. You may begin on that if you feel confident about your formative assessment problems. If you have questions, then you can give the heads up assignment a look at some of those problems, but we will work on those in class. Thanks so much for listening to the video, and I will see you in class.